Hello guys, how are you today? So basically in this quiz what I'm gonna do is I'm gonna be solving, this is the AMS quiz, the certain questions that came based on whatever we have for the periodic. A block of wood is sliding down uniformly along the triangular prism of sides 3 meter, 4 meter and 5 meter. The sides of the prism are rough. Okay, they want us to draw the free body diagram. So first of all, we need to locate all of the forces. We first have the weight, the normal push, and because they said rough, we have some friction as well. So this is how our free body diagram is supposed to look like. Now, honestly, why did they not choose this? Because here you can see the normal push is directly like balancing the mg. No, it's not the case. The normal push is not directly balancing the mg, the weight, because it's on an inclined plane, okay? So this is the correct answer. Now they want us to find the coefficient of friction of the block of wood to 2 decimal places. So they want us to find mk. Why? Because if you go up, you will see that the block is sliding down. Oh, sorry. If it's sliding down uniformly, that means the friction that we have is mk. Yes, that's correct. But if it's sliding down uniformly, that means it's in an inertial state of manner. So sigma fx equal 0, sigma fy equal 0, okay? So we need to find mu of k. We know that mu of k times Newton is, times the normal push is equal to f of k. So mu of k is very simply equal to f of k over n. Now, based on the free body diagram, let's draw the x and y axis. Let us resolve mg. mg here is going to be mg sine theta, and here mg cosine theta. Okay, you need to pay attention. And when it's an inclined plane, mg sine theta, mg cosine theta. X-axis is mg sine theta, y-axis is mg cosine, I forgot the g. G cosine theta, okay? So now, what do we do in this scenario? We have mg, which is, so mg sine theta equal fk, and then n equal mg cosine theta. Now, how do we find the value of theta? Actually, let's solve it all and then we will find the value of theta. In order to solve it, we will do mk is fk over n. So it's going to be mg sine theta over mg cosine theta. This and this cancels out and we're left with sine theta over cosine theta, which is what? Which is tangent theta. So we need to find the value of tangent theta. We will come and this is the value of theta over here, right? Now, tangent theta is opposite over adjacent, so it's 3 over 4. So 3 over 4, which is 0.75. This is the value of mu k. Now the acceleration of the block. How do we find the acceleration of the block? Very simply. They told us the block is now placed on the 3 meter side of the prism. It's placed here now. We still have the weight. We still have the friction. And we still have what? We still have the normal push. But what we could do in this scenario now, everything, all of the forces stay the same, by the way, nothing changes, except for the fact that the slope is steeper, right? We have a greater slope because the value is less, right? So how would we find it in this scenario? Because the value is less and the slope is steeper, we are gonna have what? We're gonna have an acceleration. So sigma fx is ma always, but sigma fy, it does not move up and down, it only goes down, right? So sigma fy is what? Sigma fy is 0. That means n is equal to mg cosine theta, and fx equal ma. Fx is the x component of the weight, which is mg sine theta, minus the force fk, okay? Now fk, we know it's what? It's mu times n. So mu, it's 0.75 times n, which is mg cosine theta. So minus 0.75 mg cosine theta is equal to the mass, m times a. Now, if you take out the mass, right, from here, take out the mass, and here, you can cancel the mass and the mass, right? So bye-bye mass. There's no more mass. We're left with this equation. So acceleration is g sine theta, which you can take out the g as well. So now, g sine theta minus 0.75 cosine theta equal a. Theta, sine theta and cosine theta. Now, theta changes position. So, like, just remember this equation. G sine theta minus 0.75 cosine theta equal a. theta changes position. Theta is no longer here. Now it's gonna be the inclination, or like what does it call it? The theta, like the rise of the platform is now here, not here. You don't take this, you take this. This is now theta. So they want us to find sine theta and cosine theta. Sine is opposite over hypotenuse, so 4 over 5. Cosine is adjacent over hypotenuse, so 3 over 5. What was the equation? The equation was g sine theta minus 0.75 cosine theta equal A. So g is 10. 10 times 4 over 5 minus 0.75 times 3 over 5 is equal to A. Put it on the calculator, you will get that A is equal to 3.5 meters per second squared. We'll move on to question, we don't have 13, but we have question number 16. What does it say in question number 16? A car is held in place by a light cable on a frictionless ramp. Okay, this is the ramp over here. We have the car. The car has a weight, it has a normal push, it has a friction. But what they told us is very important. The cable makes an angle of 25 degrees with the surface of the ramp, and the ramp itself makes an angle of how much? Of 10 degrees. Now, if you drew the x and y axis, it would be what? It would be like this. Now they want the tension. Okay, so if you resolve, you will see over here this is W sine theta, W cosine theta. Here this is tension cosine theta, tension sine theta. So we can say that it's held in place, meaning that it experiences inertia. If it experiences inertia, that means sigma fx equals 0, sigma fy equals 0. So what can we say now? This, I resolved them very quickly. You guys need to resolve them. You will say that on the x axis, what do we have? We have W sine theta equal T cosine theta, because everything left equal everything right. Now, on the y-axis, everything up, so n plus T sine theta equal W cosine theta. They want the tension in the cable. Tension in the cable is W sine theta over cosine theta. Now, this theta is different among the tension and the W. For the W, the theta is 10 degrees. But for the tension, the theta is 25 degrees. Okay, so sine 10 over cosine 25, and W is how much? Is 1500 times G, which is 10. So W equal mg. Okay, so you put it on the calculator. It will be 15,000 times sine 10 over cosine 25. This will give me the value of T to be what? To be 2,874 newtons. Now, how do I find the value of N? N is equal to W cosine 10 minus T sine 25. So W cosine 10, it's going to be 15,000 cosine 10 minus 2,874 sine 25. So it will give me 13,558 newtons. So 13,558 newtons. We'll move on to question number 17. A load hangs in equilibrium using two cables that form an angle of 120 degrees as shown below. So first thing you're gonna do is you're gonna draw the weight, which is 519 newtons. You will draw now the y and x axis. You have a tension here. Okay, now you need to resolve this. How much is the angle here? It's not 120, it's 120 minus 90, which is how much? Which is 30 degrees, right? So if we were to resolve, we would have over here the tension. We'll call this tension 1. This tension 1 would be tension 1. Now you need to apply the triangle method, and you will see that over here it's going to be what? It's going to be T1 cosine theta. And when you do it over here, you will see that it is T1 sine theta. And this tension over here is T2. So it's in equilibrium, it's in inertia. Whenever it's in inertia, directly you say sigma fx equals 0, sigma fy equals 0. So T1 sine theta equal T2. T1 cosine theta equal 519. Theta is how much? Theta is 30 degrees. Okay, so that means T1, which is the tension in AC, is how much? Is 519 over cosine 30. If you put it on the calculator, you will get your answer to be what? You will get your answer to be 600 approximately, so 599.9600. And then the tension in BC, it's what? It is tension 2. We know that tension 2 is T1, which is 600 times sine 30, which is what? Which is 300 newtons. We'll move on to question number 18. This is very easy, okay? The ball exerts a force on the wall to the right. The wall exerts a force on the ball to the left. Okay, this is easy. We move on to question number 19. Okay, where's my paper? A 60 kg skier descends from a hill. At the bottom of the hill, the skier moves at the speed of 10 meters per second. The skier continues to move horizontally for 40 seconds before stopping. Take g to be 10 meters per second squared. So they're ignoring him descending. Now he's on a flat surface, right? He has his weight 60 kg or 600 newtons, right? And he's moving at a constant speed of 10 meters per second. Okay, so from 10 meters per second he goes to rest, like he stops, so 0. And how much is the total time? 40. So 0 minus 10, v final minus v initial over the time will give me the acceleration. 0 minus 10 over 40, that is minus 1 over 4 meters per second squared. This is the acceleration. Now we don't forget about the normal force as well. And what do they want? They want the friction force. My friction force is backwards. There is no pushing force, okay? So what is the value of my friction force? Because it's negative. Why is it negative? It's negative because it opposes, right? The friction will oppose the direction of motion, right? So if it's moving like this, then the friction is going to go in the opposite direction, so that's why it's going to be negative. But we don't take it negative, we take it in absolute value. So now it's going to be what? It's going to be sigma fx equal ma, because there's acceleration. So sigma fx is only friction. Friction is equal to 60 times 1 over 4, which is what? Which is 15 newtons. Now the coefficient, what's the value of the coefficient? Coefficient is the force friction over the normal. So it's going to be 15 over 600, which is 0.025. We'll move on to question number 20. On a thread, okay, very nice question. We have a pulley and two loads, 0.75, 0.85. One is heavier than the other. Of course, one is higher than the other as well. So here we say that this is 7.5 Newton. This is 8.5 Newton. Within 2 seconds after the start of the movement, each travels a distance of 1.2 meters. What's this? This is the delta x. Delta x is half at squared plus v initial. It was at rest, right? Plus v initial t. It was at rest, that means v initial is 0, so we will remove it. And then it was at go and it accelerates. So delta x is half at squared. So delta x, which is 1.2, is equal to half times acceleration times 2 squared. This will give me the value to be what? To be 0.6 meter per second squared. Now how do I find the acceleration of gravity? Very simply, the acceleration of gravity is g, right? And we know that sigma Fy is equal to what? Is equal to ma. And we know that the 7.5 newtons goes up and the 8.5 goes down. What does this mean? This means 8.5 minus tension is equal to the mass, which is 0.85 times the acceleration a, okay? And then the tension, because it's greater than the 7.5 newtons, it will pull it up, minus 0.75 times the acceleration a. Now we add them together. When we do end up adding them together, we will get that 8.5 minus 7.5 is 1. 1, the tension and tension cancel. So you do like this, okay? And then 0.85 plus 0.75 will give me 1.6a. Oh, actually, I did a mistake. Very important, I did this mistake. That's what we are looking for. We're looking for g. So how did I solve without having g? You see this very silly mistake I did? So 0.75 g, 0.85 g. Now this changes everything for me now. So this becomes 0.85 g minus whatever, and then 0.75 g, okay? Now when you add them together, 0.85 minus 0.75, this is 0.1. So 0.1 is equal to 1.6a. Now we found the value of a to be over here 0.6. So 0.1 is equal to 1.6 times 0.6 meter per second squared. So move 0.1 here. It will not be 0. We'll call it x over here. So, no, not x. Let's call it g. Sorry, it's 0.1 g over here. So G is then equal to 1.6 times 0.6 over what? Over 0.1. And this will give me an answer of 9.6, which is my answer, 9.6 meter per second squared. Now question 21, they want the magnitude of the resultant force. Okay, how do we find that? We need to resolve first of all F2. It will become into F2 cosine 45, F2 sine 45. F2 is 30 and 30. Because they're going in the same direction, and F1 is what? F1 is 40. Because they're going in the same direction, it's going to be 40 plus 30 cosine 45, right? So it's going to be radical 30. So how do you find the magnitude? Radical 30 cosine 45 plus 40 squared, because it's they're going in the same direction, you add them, plus 30 sine 45 squared. So when you do this, you're going to get your answer, which is 64.7. You rounded 64.8 newtons. Now, how do you find the direction? Of course, the direction is tangent inverse y over x. My y is 30 sine 45. My x is 30 cosine 45 plus 40. Put it on your calculator, you will get that theta, or the direction, is 19.1. Last but not least, last question, very important question. The diagram shows a particle A of mass 6 kg. Okay, so I'm gonna assume that G is 9.8 because they didn't give it to me, so this would be 58.8 newtons, and B of 4 kg, so this would be a weight of 39.2 newtons. And it's at rest. So we also have the normal push and the tension force and the tension force. What is the acceleration of the particles when the system is released from rest? When the system is released from rest, we will have sigma Fy equal to 0 first of all. However, sigma Fx is equal to ma. This is for which particle? For particle A, whereas for particle B, it is what? It is sigma Fy, which is equal to m. Right? This is very, very, very important to know the difference, okay? Because A is on the, like, it has a surface, B is hanging on a rope. This is why sigma Fy is ma, because it's the only force, okay? So what is sigma Fy? B goes down, so that means the weight, okay, which is 39.2, is stronger than the tension, so it's gonna be ma, right? Whereas in A, it's going up the plane. That means the tension is stronger than what? Is stronger than the x component of the weight. That's stronger than W sine theta, right? Perfect. Theta is how much? Theta is 30. It's equal to what? To ma. What is the mass of block B? The mass of block B is 4, so 4a. And the mass of block A is 6. Now, what we can do is we can add these two together. Of course, you need to add them. So 32.9 minus W, how much was the weight? The weight was 58.8 minus 58.8 sine 30. How much would this give me? 39.2 minus 58.8 sine 30. This would give me an answer of 9.8. So 9.8, and then the tensions will cancel out. Basically, add these two equations together, is equal to 4a plus 6a, which is how much? Which is 10a. That means acceleration is 9.8 over 10, which is 0.98, which is approximately 1 meter per second squared. Now, how do you find the tension? We can say that tension is 39.2 minus 4a. Acceleration is 1. So it's going to be 39.2 minus 4, which is 35.2, right? So what's the closest answer to 35.2? It will be 36. And that's it for this video. Thank you guys for watching. I hope you enjoyed and have a wonderful day.